What's up, guys? In this video, what we're going to do is review some proportion problem solving. Here's the first problem. Alex's cat eats 3 cans of cat food in 5 days. Alex is going to go away for 30 days. A friend is offered to feed the cat. How many cans of food must Alex leave for his cat while he is away? Okay, so I'm finding the cans of cat food. So cans and days are the 2 units I have in the problem. X is the days, and because X is always time, and then Y is the cans. Then cans per day. Well, they don't really tell me the cans per day. So what I'm going to do is go to this orange sheet of paper, make a table. I'm going to put my days, my time here. I'm going to put my cans right here. All right, well, one ratio I know is that there was 3 cans in 5 days. So 5 days, 3 cans. And I'm just going to ask a question. If he eats for 0 days, how many cans of cat food would he need? Well, you'd need 0. Okay, so that's what tells me that I can go ahead and use proportions to solve the problem. Now, you need to put your X, your time unit, on the bottom, or it won't, or on this problem, not. Yeah, just put the time on the bottom. And cans is what I'm trying to figure out, so that's X. And I know one of the ratios is 5 days and 3 cans, so 5, 3. And he's going to go away for 30 days, so I'm going to put 30 in for days. And then I just cross multiply and divide. I multiply 3 times 30, and then I divide that product by 5, and I get 18. So 18 cans. Okay, next problem. 2 people are smashing boxes. I can smash and break down 1 box and 14 boxes in 1 minute. Another person can break and smash 14 boxes in 3 minutes. If we have 350 boxes to smash, how long will it take us working together? So I'm finding the number of minutes this is going to take. So I have boxes and minutes. And the times X, and the other unit's Y. And then per, boxes per minute. Okay, boxes per minute. Well, 14 boxes in 1 minute is 14 boxes per minute, but then there's another person in there with me, so I don't know what it's going to take us to working together. Okay, so I don't know that. So what I'm going to do actually on this paper is make 2 tables because we have 2 ratios for 2 different people. So minutes, boxes, minutes, boxes. So I'm given one ratio, 14 boxes in 1 minute, so 1, 14. And then for the other person, he does 14 boxes in 3 minutes, so it'd be 3 and 14. Well, if I work for 0 minutes, I'm not going to get any boxes smashed down. And this other person, same thing. If he doesn't work for any time, there's no boxes he can smash. So that gives me the go-ahead to go ahead and set up my proportions. And we want to put our time unit in the denominator. And then boxes on top. So I'm looking for the minutes. Minutes is the answer to the problem, and minutes is X, so X minutes. And when they're working together, they have 350 boxes to smash, so that's 350 boxes over X minutes. Now, I need 2 ratios on this side of the proportion because there's 2 tables. 1 minute, 14 boxes. Okay, so 14 over 1. And then, again, you want to keep putting your time unit in the right place. That's 3 minutes, 14 boxes. So 3 minutes, 14. And I add these together. So 14 over 3 plus 14 over 1, or 14. I get a mixed number, 18 and 2/3. So what I do is I hit second, and then the ABC button, and then that makes it 56 over 3. It converts it into an improper fraction. Okay, and then keep your 350 over x, and you can cross multiply and divide. So 3 times 350 divided by 56. And I get 18.75. Or let's round that up to 9. Now 18.75 is okay. It'd be 18 minutes 45 seconds. All right, next problem. There are two cars that travel for the same amount of time. One car travels at an average speed of 50 miles per hour mph, while another travels at an average speed of 58 miles per hour mph. One car travels 120 miles further than the other car. How many miles did each car travel? So I'm not going to use my units necessarily because we're talking distance, speed, and time. So distance, speed, and time, what we're going to do is make that table, split it in half, and there's going to be 4 columns. Okay, so 1 and 2. So I have speed, distance, and time. And I know that if I don't know the speed, I've got d divided by t, d over t. If I don't know the distance, I would multiply the speed by the time. If I don't know the time, I would take the distance divided by the speed. Okay, the speeds we know, though. We have 50 miles per hour for one car and 58 for the other. So let's cross those numbers out. Now, distance is just miles itself, and I see 120 miles, but it says, neither car actually went 120 miles. One just went 120 miles further than the other. So what I'm going to do is the slower car, I'm going to call his distance x, and then I'm going to call the faster car x plus 120. I can cross that 120 out. Now, the time, I have no idea, okay? So I'm going to use the distance over speed ratios. So d over s, okay? So the distance here is x and the speed's 50. The distance here is x plus 120 and the speed is 58. And it says they traveled for the same amounts of time, so these two ratios are equal and they form a proportion. So x over 50 is equal to x plus 120 over 58. Now, I can't just cross multiply and divide here. First off, there's two x's. Second of all, this x has an operation of plus 120. So I need to use my A, B, C, D cross products. So A, B, C, D. So A is x and B is 58. And C is x plus 120. I'm going to put a 1 in front of that. I'll put a 1 in front of that too. And then 50. So here I just take 1x times 58. That's 58x. And then I distribute 50 to each of these. And that's going to be 50x plus 120 times 50 is 6,000. And I have x's on opposite sides, so I need to balance out the smaller x. That's 8x equals 6,000. Divide both sides by 8. 6,000 divided by 8 is 750. So 750 is the distance that the slower car traveled, 750 miles. Then to find the other one, if you know that this is 750, then the other distance you don't know, you can take 750 and add 120 to it, and that's 870. Okay, next. Gas currently costs $2.09 per gallon, but is expected to increase 15% over the next month. How much will gas be after the increase? Okay, so I'm going to use, there's two ways you can do it. I'll show each way. You pick the way. If you like proportions, here's the way we do it. Percent over 100%. But I need to change the percent because it's increase of 15%. So I take 100 plus 15, and that's 115%. Now, since I changed the percent, this is a new original, okay, kind of problem whenever we change a percent. And current cost means it's the original. I kind of forgot to put that. That's the original, so I would put that down here. And I'm looking for the new price because it says how much will the gas be after the increase. That means I don't know the new. So again, I multiply 115 times 2.09, and I divide by 100, and that's $2.40. Okay, now if you prefer to write the equation, here's what you do. It's the original. You got two factors on this side and then just one on the other. So original multiplied by your percent equals the new. All right, so since 209 is the original, that's what we put there. And then my percent, again, it's 15% increase. So I take 100 plus 15, that's 115. But if you're using this method, you have to convert 115 to a decimal, which is 1.15. And then the new price is unknown, so that's X. So you take 2.09 times 1.15, $2, just same thing, $2.40. Okay, my next problem. Pick one or the other. You don't have to use both, whichever one's easier for you. A furniture store sells a furniture set for $990. A person offers to buy it for $850. What percent of the original price are they willing to pay? So, now they don't even give you a percent in here, so you really can't change it. So that's X, okay? And since I didn't really ever change the percent like I did here, it's part over whole. Now the part whole should be easy to figure out here, okay, to be honest with you. Because you know the part would be the 850, and then the whole would be the larger value, 990. And then you can just cross multiply 100 times 850. Divide by 990, and I get $85.86. Or no, that's a percent. I'm sorry, that's a percent. So it'd be 86%. So 86%. Okay, now if you prefer the other method, remember you're not really changing the percent, so we're not going to go with original and new. We're going to go with whole and part. And I don't know the percent, so that's where my X is at. And then the whole would be 990. And then the part would be 850. And then I divide both sides. It's kind of an equation here, so I divide both sides by 990, and those cancel. And then divide that side by 990. So 850 divided by 990 would be 0.85, but you got to understand that's a percent, so that would be 86%. Most people prefer this way, but that's fine. Okay, next one. I'm going to underline letter E. The letter E makes up 1/8 of the typical document written in English. A document contains 2,800 total letters. How many of those letters would be E? So it's 1/8, and a fraction by definition is part over total. Now we need to define the part, okay? The part is defined by letter E. It says 2,800 total letters, but those aren't letter E's, so that doesn't belong here. That's your total. Then X goes right here. Then I cross multiply and divide. So 1 times 2,800 divided by 8 is 350. So it would be 350 E's in the document. Okay, guys, that's what I have to say on that. I hope it's been informative, and yep.